All right, Algebra 1, here we go, guys. We are in section 3 today of chapter 9. This is all about special products of polynomials. So I know that this section has been all about, the chapter actually has been all about polynomials, okay? But now we are doing, as it says, special products. And so that's when you're going to have, right here, a couple binomials, all right? So in other words, that's two terms separated by either a plus sign or a minus sign, and they may take those terms, if we zoom in, and bring it to the second power, okay? Which would mean that basically you're going to take whatever's in the parentheses and write it twice, and then you would do double distributive property, okay? And then you would expand it out, and that would create a trinomial. And here's an example of a minus sign in a parentheses, second power. That means you're going to take this and write it twice. And then you're going to do double distributive property. And again, it will create a trinomial. Okay. So when you guys see notes that are highlighted, that means those are very important. When you see a key concept chart like this right here, that means that is important. But then in the chart, if you see stuff that's highlighted, that means you really need to copy that down. Okay? So special products, we're going to working with binomials. We're going to square those binomials. And then you may have a different situation, or maybe you have two binomials that are perfect opposites. And here's what I mean by that. Look at this. We have two binomials. And by perfect opposites, I mean we got a plus sign, we got a minus sign. But inside of it, this is all the same. So a perfect opposite here with a plus and a minus, but everything else matches up. If that is the case, then what's going to happen is it's a special product where the middle term of the trinomial will drop out. And these are the middle terms right here. These middle terms, they're the ones that possess just a single x. And if it's a special binomial, meaning these all line up perfectly, but it's just a plus sign and then a minus sign, notice it's not creating a trinomial. It's creating another binomial, but it's special. There's no middle term, right? But it does have the squared at the beginning. Okay, so it's a special binomial right there. All right, these are the two main concepts being addressed in today's notes for section 3. Okay, so there's the note page. Copy down everything that's highlighted on that page into your notes. All right, you can pause it, take the time to do that. Now let's move into the example problems. All right, so let's zoom in right here. First example problem. So as you can see, we have our binomial squared, all right, to the second power. That means we have this, but write it twice. Okay. Okay, and we're just going to do a double distributive property. All right, and you guys are going to see that means that we are taking the first term, bring it over there. Then we're going to take the second term and bring it over there. Okay, both terms have to be crossed over or else it's not going to be working out. Okay, so let's go ahead and show the 2x, and then we're going to do the 1. Okay, all right, so 2x times 2x gives us 4x squared. 2x times 1 gives us a plus 2x. 1 times a 2x gives us another plus 2x. And then 1 times 1 just gives us 1. Now these terms right here in the middle, they are like terms, 2x and 2x. They both share the same variable, same exponent. So they could be combined together to give us 4x. The plus 1 has nothing to go with, and the 4x squared had nothing else to go with. So this is our solution right there. Okay, so make sure that you see always go in descending order of exponents. Notice again, we got 2, then 1, then no exponent. And we just are expanding it out. There's a 2, so write this twice, and then double distributive property. All right, there you go. Okay, so let's do it again. This time, let's show it with a minus sign. Let's do it with another variable, just to show you that the steps don't change. There's your binomial. We're going to write it twice and do a double distributive property, just like we did in example problem number 1. Okay, so all I did here was write it twice, double distribute, same steps. 4x times 4x will give me 16x squared. Don't forget, when you distribute, you're multiplying. So rules are a little bit different with the exponents. Then do a 4x times a negative y. We can't really combine anything here. So you're just going to have that negative go right there, 4xy. All right, now this one, a negative y times 4x, it's the same thing, negative 4xy. And a negative y times another negative y, both are negatives. So it's going to create a positive y squared, because it's y times y squared. And then don't forget, like terms always right there in the middle. 16x squared had nothing to go with. Negative 4 and negative 4. We are now using addition and subtraction. So that makes a negative 8. And remember, when you're using addition and subtraction with variables and exponents, you keep the same variable and exponent. All right, so xy is still there, and then plus y squared. All right, there's the answer for that one. Okay, we got a couple more example problems to go. All right, this one goes into that category of being the perfect opposites. All right, we got a 2x and a 2x. We got a 1 and a 1, but here's our perfect opposite part. There's the plus, there's the minus. Here's the easy way to do these. As long as they fit those parameters, those are the same, those are the same, but then it's a plus and a minus. As long as those parameters are set up, then here's all you have to do. Go first to first, last to last. That's it. Because the middle terms will cross each other out, so you don't have to do that. But that is also making sure that you followed those guidelines to check that all the parameters make it a binomial that's a perfect opposite. So 2x and 2x make 4x squared. 1 times a negative 1 make negative 1. Boom. That's it. So these work out very quickly, very easily, as long as, again, the parameters are set. 2x, same thing, 2x. There's a 1, there's a 1, and they have to be opposites, positive and negative. All right? Last example problem, here we go. There's an x, there's another x. A 3y, there's another 3y. An opposite, positive and negative. So they meet all those parameters. Okay? Remember, first goes to first, last goes to last. And that is only the case, again, when it is a perfect opposite with the binomial. All right? There's an x, there's an x. That matches. 3y, 3y. That matches. And opposite signs. Okay. So x times x makes x squared. 3 times 3, actually a positive 3 and a negative 3 make a negative 9. And y times y make y squared. Okay, that's it. That is the final answer for these example problems. There's the whole page right there zoomed out so you can make sure you see it, understand it, copy it, got it all down there. All right, guys, ask questions in class. Make sure that you are prepared. I'll see you in the next video.